Reality might be written in a hidden geometric code. This is not a science fiction story, but a serious scientific possibility that reshapes our entire conception of the cosmos. Galileo himself declared that the universe is written in the language of mathematics. By the end of this journey, you will see the cosmos not as a chaotic expanse, but as a structured, logical system. We will investigate why black holes might be holograms and how the entire universe could be a single, frozen geometric object. What does it mean for our existence if the fabric of reality is ultimately a form of information? Plato's vision of a universe built from perfect shapes might seem like mystical speculation, but his intuition resonates in a startling way with modern science. He assigned fire to the sharp, piercing tetrahedron, earth to the stable cube, air to the smooth octahedron, and water to the multifaceted icosahedron. For the heavens, he reserved the most complex form, the dodecahedron, as the shape of the cosmos itself. This was more than just philosophy. It was an early declaration that the chaos of our world emerges from an underlying geometric order. And today, we find this idea is not so far-fetched. Look at a snowflake under a microscope. Its intricate, six-fold symmetry is a direct result of the geometric arrangement of water molecules. A diamond's incredible strength comes from the rigid, repeating cubic lattice of its carbon atoms. Scientists studying quasi-crystals have discovered materials with atomic structures so orderly and complex they were once thought impossible, forming patterns that never quite repeat, yet are mathematically perfect. These are not just pretty patterns, they are the operating system of reality, written in a language of shapes and angles. This ancient wisdom pushes us to ask a profound question. If the stuff we can see and touch is governed by geometry, what about the invisible fabric of everything, the stage upon which the universe plays out? What about spacetime itself? This leads us to a startling possibility. What if our universe, in all its vast, three-dimensional glory, is actually a hologram? Not a shimmering illusion, but a cosmic projection. This is the core of the holographic principle, a radical idea that emerged from a seemingly unrelated puzzle, the thermodynamics of black holes. Scientists studying these mysterious objects made a bizarre discovery. They found that the maximum amount of information, the entropy, a black hole can contain is not proportional to its volume as you might expect. It is proportional to the surface area of its event horizon. This was a profound clue. It suggested that all the information needed to describe everything within a black hole, every star, every planet, every atom that fell in, could be perfectly encoded on its two-dimensional boundary surface. The three-dimensional interior was, in a sense, redundant. It was just a projection of that data. Extend this logic to the entire cosmos. The holographic principle proposes that our entire three-dimensional universe, with its galaxies, its planets, and us, could be a magnificent projection from a two-dimensional surface at the edge of everything. Think of it as the universe's ultimate data compression scheme, a movie file so perfectly compressed that it doesn't just look three-dimensional, it becomes three-dimensional. The world you see and feel is the decoded image. This means the fundamental code of reality, the ones and zeros of existence, might be written on a flat, two-dimensional screen we can never see. The solidity of the chair you are sitting on, the depth of the night sky, the very sensation of moving through space, all of it could be a holographic illusion emerging from a lower dimensional reality. It forces us to confront a staggering question. Is three-dimensional space even a fundamental property of the universe? Or is it just a convenient, emergent way for us to experience the data? But if the universe is a holographic projection, what is the nature of the projector itself? This leads us to an even grander geometric vision, one that suggests our cosmos is not a one-time event, but part of an infinite, repeating cycle. This is the second principle, conformal cyclic cosmology, proposed by the Nobel laureate Roger Penrose. It asks us to envision the universe not with a single Big Bang, but as a series of infinite cycles, each one a complete cosmic lifespan called an eon. Each eon begins in a fiery, high-energy state and expands outwards over trillions of years until all matter eventually decays and even black holes evaporate. What remains is an endless, cold, and empty expanse. This seems like a final, bleak end. But according to Penrose, this state of near-nothingness and the state of the universe at the very moment of the Big Bang are geometrically the same. They are both perfectly smooth, devoid of any scale, and possess an almost pure symmetry. Because they are geometrically identical, one can transform into the other. A conformal transformation, a geometric operation that smoothly rescales time and distance, can connect the infinite far future of one eon to the explosive beginning of the next. In this breathtaking model, the universe does not end, it resets. The death of one cosmos becomes the birth of another, in an endless, cyclical dance governed by elegant geometric rules. This is not merely a reboot where everything is erased. Penrose suggests that faint imprints, perhaps in the form of subtle gravitational waves or what he calls Hawking points, could carry traces of information from one eon to the next. It is as if the cosmic code is translated, compressed, and then decompressed into a new reality. The geometric structure of one universe provides the blueprint for the next. This grand vision pushes us to consider the ultimate architecture of reality. Is the cosmos a single, fleeting event, or is it an eternal, self-sustaining system, written in a geometric language that transcends time itself? So what are the fundamental building blocks in this cosmic code? We have seen the grand holographic projection and the endless cyclical rebirth. Now we must peer into the microscopic weave of reality itself, into the very fabric of spacetime. This is the domain of the third principle, an approach known as causal dynamical triangulations. Think of the universe not as a smooth, pre-made sheet, but as a vast, dynamic mosaic. Its most basic components are unimaginably tiny geometric pieces, simple shapes like triangles and their higher dimensional cousins, the tetrahedrons. These are the Lego bricks of existence. The theory proposes that we can build the entire cosmos by gluing these fundamental pieces together according to a strict set of rules. The most important rule is causality, the principle that cause must always precede effect. This ensures that the network of triangles respects the flow of time, that every connection makes logical sense. On their own, at the smallest scales, these pieces are a chaotic, jumbled quantum foam, a turbulent sea of fluctuating geometry. There is no up or down, no before or after, just pure potential. But then something remarkable happens. When scientists run computer simulations that connect trillions upon trillions of these causal triangles, a stable, smooth structure begins to crystallize out of the chaos. The random quantum noise settles down, and a clear, four-dimensional universe emerges, complete with the three dimensions of space and one of time we navigate every day. It is like watching a pixelated image resolve into a flawless photograph. From a frenzied dance of simple geometric rules, the familiar, continuous stage of our reality spontaneously assembles itself. This is not just a philosophical idea. It is a working model that shows us how complexity and order can be programmed from the bottom up. the solid ground beneath your feet, the vast distances between stars, the relentless forward march of time. All of it could be the final product of an unimaginably complex calculation running on the universe's own geometric processor. This leads us to a final, almost unbelievable synthesis. What if these three principles, the hologram, the cycle, and the triangulation, are not separate ideas, but different perspectives on the same underlying truth? These four-dimensional triangles and holographic projections point toward a universe built from geometry. But does this idea hold up when we test it against the most complex interactions in nature, the frantic dance of subatomic particles? For decades, physicists have relied on a powerful but cumbersome mathematical tool to predict what happens when particles collide. The calculations are so monstrously complex they can fill thousands of pages with algebra, a labyrinth of probabilities and forces. Yet a discovery has emerged that cuts through this computational jungle with breathtaking elegance. It is called the Amplitudehedron. Imagine a perfect, multifaceted geometric object, a jewel existing in a world of many dimensions. This shape is not just a helpful diagram, it is the reality of the particle interaction itself. The volume of this shape, its intricate geometry, directly encodes the final outcome of a particle collision. Every possible way particles can scatter and interact is not a separate line in a long calculation, but is already contained within the angles and facets of this single, beautiful form. To calculate the probability of a specific outcome, a physicist does not need to wrestle with endless equations. They simply calculate the volume of the corresponding slice of the amplitudehedron. It is like swapping a 1000-page instruction manual for building a house with a single, perfect blueprint where the house simply materializes when you look at it. The profound implication is that our most fundamental laws of physics might be mere shadows. Concepts we considered absolute, like locality, the idea that objects are only influenced by their immediate surroundings, and unitarity, the conservation of probability, appear to be secondary. They are not the foundational rules of the game. They are emergent properties that bubble up from this deeper, purely geometric reality. The frantic world of quantum forces we observe is just the surface manifestation of a silent, perfect, and timeless geometric truth. The universe is not just described by mathematics, it appears to be mathematics in its most pure and tangible form, a cosmic code written not in ones and zeros, but in shapes and volumes. The frantic dance of particles finds its geometric counterpart, but what about gravity itself? This final piece of the puzzle takes us to the very limit of the small, to a realm where the smooth stage of spacetime shatters. At this scale, the universe is not a continuous fabric. It is granular, a digital tapestry woven from the most fundamental threads of reality. This is the vision of loop quantum gravity. It proposes that space itself is not infinitely divisible. It is woven from tiny, one-dimensional loops. Think of them not as little strings, but as the most basic stitches in the fabric of existence. These loops do not exist within space. They are space. Their connections, their intersections, are what define the very concept of location and distance. When these loops weave together, they form a vast, evolving structure called a spin network. This cosmic web is a graph of relationships, a map of pure information. Each node and each link in this network carries a specific, quantized value. This means that area and volume themselves come in tiny, indivisible packets. You cannot have half a unit of space, just as you cannot have half an electron. The space around you has a finite, though unimaginably dense, pixelated structure. This network is not static, it evolves. As time passes, the spin network changes its configuration, creating a complex, foamy history of spacetime known as a spin foam. Imagine a freeze frame of a bubbling liquid, capturing every connection and change in a single, intricate geometric structure. This spin foam is the four-dimensional story of the universe's geometry, a record of how every quantized piece of space has transformed into every other. This provides a breathtakingly elegant solution to a century-old problem. It suggests that gravity is not a mysterious force acting on a stage. Gravity is the geometry of the stage itself, and this stage is quantized. The gravitational field is simply the ever-changing pattern of connections in this cosmic spin network. In this view, geometry is not a passive backdrop. It is the dynamic, living code that dictates how everything moves and interacts. The universe is not built of things in space. It is built of relationships, a cosmic web of pure geometric information. The bizarre rules of the quantum world have always defied common sense. Particles that exist in multiple states at once, or that communicate instantly across the universe, seem to shatter our classical understanding of reality. Yet what if this strangeness is not true randomness, but the visible output of a hidden geometric engine? Consider one alternative to the standard view, the pilot wave theory. In this interpretation, a particle is not a spread-out cloud of probability. It is a single, definite thing like a tiny boat, but this boat is not drifting aimlessly. It is guided by a pilot wave, a complex, invisible landscape of information that dictates its path. This wave is not a physical force in the usual sense. It is a geometric structure, a hidden topography of reality that the particle simply serves. The particle's seemingly random behavior, like appearing in one place or another during an experiment, is not random at all. It is the inevitable result of its position on this invisible geometric map. This idea extends to the most puzzling quantum phenomenon of all, entanglement. When two particles become entangled, their fates are linked, no matter how far apart they travel. Measure one, and the other instantly responds. This spooky action at a distance baffled even Einstein. But from a geometric viewpoint, this could be a literal connection. Some physicists propose that entangled particles are not sending signals faster than light. They are linked by microscopic bridges in the fabric of spacetime itself, structures akin to wormholes. These are not tunnels for spaceships, but fundamental geometric features, stitches in the cosmic code that shortcut the apparent vastness of space. In this light, entanglement is not magic. It is topology, the geometry of connection. The particles were never truly separate in the informational landscape that underlies reality. Their seemingly independent existence in our three-dimensional world is just a projection of a deeper, unified geometric whole. This reframes everything. The quantum enigma, with all its apparent chaos and probability, might be the surface-level shimmer on a profoundly structured and geometric foundation. The gap between the frantic quantum dance and the smooth cosmic stage begins to close, both emerging from the same hidden code. This ancient light, the cosmic microwave background, is the oldest picture we have of our universe. It is a snapshot from a time when the cosmos was just a hot, dense plasma, a mere 380,000 years after the Big Bang. We have long seen it as a thermal echo, a uniform glow of leftover heat. But perhaps we have been thinking about it all wrong. This glow might not be a simple relic. It could be a message, a cosmic data stream frozen in time, waiting for us to learn how to read its geometric language. The map of the CMB is remarkably uniform, a canvas of tiny temperature variations that correspond to the seeds of all future structure, the galaxies and voids we see today. Yet within this uniformity, there are strange anomalies, features that do not fit the standard story. Certain large-scale patterns seem to align in ways that defy simple chance. creating what some scientists call an axis of evil, a preferred direction in the cosmos that should not exist. There are cold spots, regions far colder than our models predict, vast expanses of silence in the cosmic hum. One compelling explanation is that these are not mere statistical flukes. They could be cosmic scars, the imprint of a more complex geometry that existed before our Big Bang. Perhaps our universe is not an isolated bubble, but one of many in a vast multiverse. In this scenario, the cold spot or the strange alignments could be a bruise, the signature of our young cosmos brushing against a neighboring universe in the moments of its birth. The geometry of that collision, the shape and angle of the impact would have left a permanent mark in the Siamese patterns. Reading this data stream is the ultimate cryptographic challenge. We are not looking for a simple message written in ones and zeros. We are trying to decode the universe's initial boot-up code, the fundamental geometric rules that were loaded at the very first instant of time. The specific patterns of hot and cold we see are like the output of a cosmic compiler, the result of the universe executing its first lines of geometric instruction. Every subtle asymmetry, every unexpected alignment, is a clue pointing back to the true architecture of reality. It is as if we have found the universe's original source code, but we have not yet figured out the programming language it was written in. Could these faint temperature variations be the physical manifestation of a spin network's first configuration, or the holographic data imprinted on our cosmic horizon? The search for answers continues, pushing us to look for even more subtle signatures, like the specific swirls of polarized light that could reveal the passage of primordial gravitational waves, the tremors from the universe's very first geometric vibrations. Stretch the map of the universe across the largest distances we can measure, and a single, breathtaking pattern emerges. Galaxies are not scattered randomly like stars in the night sky. Instead, they cluster into a vast cosmic web, an intricate architecture of brilliant filaments and nodes separated by immense, dark voids of near-nothingness. This is the universe's largest structure, and it holds a secret in its shape. Zoom in on any single filament, and you will find smaller clusters of galaxies. Zoom in again, and you see the same pattern of clustering repeated. This self-similarity, where the same basic form appears at different scales, is the hallmark of a fractal. It is the same geometric principle seen in a snowflake, where a tiny branch mirrors the structure of the whole, or in a fern frond, where each small leaf is a miniature copy of the larger one. From the branching network of neurons in your brain to the turbulent flow of a river delta, fractal geometry appears to be a universal language of organization for complex, evolving systems. So why would the entire cosmos on its grandest stage choose to speak this same language? The answer might lie in a simple, iterative rule, a single line of cosmic code executed over and over. Imagine a process where gravity pulls matter into small clumps. Those clumps attract more matter into filaments, and those filaments connect at nodes. This basic geometric algorithm, running for billions of years, could build the entire cosmic web from the bottom up. The presence of fractals from the microscopic to the macroscopic is a powerful clue. It suggests the universe does not need an infinitely complex blueprint. It needs only a simple, elegant, and recursive geometric instruction, a fundamental line of code that, when set in motion, builds all the complexity we see. This fractal signature could be the universe's own signature, written across the sky, pointing us toward the elegant, algorithmic engine at the heart of everything. This hidden geometric code relies on a principle more fundamental than shape alone, a principle of perfect balance. Symmetry is the silent engine of reality. It is not merely about a butterfly's wings or a snowflake's design. In physics, symmetry is a ruthless mathematical rule that dictates what can and cannot exist. The entire universe operates on invariances, properties that must remain unchanged no matter how you transform your view. Rotate the cosmos, boost to near light speed, or look at it in a mirror, and the underlying laws of physics will look exactly the same. This consistency is not an accident. It is the deepest clue we have to the universe's architecture. The mathematical language that describes these invariances is called group theory. Think of it as the ultimate classification system for all possible symmetries. It does not care about a specific object. It cares about the set of all possible transformations that leave an object's essential structure intact. The rotational symmetry of a circle, for instance, belongs to a specific group defined by all the ways you can spin it and have it look the same. This abstract mathematical framework is the bedrock of our most successful theory of particles and forces, the Standard Model. The electromagnetic force, the weak nuclear force, and the strong nuclear force are each governed by their own specific symmetry group. These groups are like the core operating rules in the cosmic code. They dictate how particles can interact, what charges they must carry, and even why certain particles must exist at all. The Higgs boson, for example, was predicted because the mathematical structure of the electroweak symmetry group demanded it for consistency. The particle was a necessary consequence of the symmetry, a missing piece required to complete the geometric pattern. The drive for a grand unified theory is at its heart a search for a larger, more beautiful symmetry. Physicists are hunting for a single, overarching symmetry group that seamlessly contains the symmetries of the Standard Model. At the incredibly high energy levels of the early universe, this master symmetry would have been manifest, and all forces would have been one and the same. As the cosmos cooled, this perfect symmetry broke, shattering into the distinct forces we observe today, much like a perfectly symmetrical crystal forming distinct facets as it solidifies. This suggests the ultimate code of reality is written not in complex equations, but in the pure, elegant, and perhaps simple language of symmetry. The chaotic diversity of the universe, with its myriad particles and forces, could all be the emergent consequence of one perfect, pristine, and invisible geometric balance. This radical idea pushes us to the final frontier of this geometric mystery. The mathematical universe hypothesis presents the most extreme and logical conclusion of our journey. It proposes that our universe is not merely described by mathematics, which is already a profound statement. It asserts that our universe actually is a mathematical structure. Think about the world around you, the chair you are sitting on, the stars in the night sky, the very thoughts in your mind. According to this hypothesis, all of it is a complex, self-consistent mathematical object. The physicist Max Tegmark argues that there is no separate, fluffy physical substance. There is only mathematics. The laws of physics are not rules imposed upon reality from the outside. They are simply the intrinsic properties of the specific mathematical structure we find ourselves within. This completely dissolves the line between the map and the territory. We are not studying a model of the universe. We are the universe studying its own mathematical essence. The hidden geometry we have been exploring, from the hologram to the spin foam, is not an approximation. It is the literal, fundamental reality. The cosmic code is not a representation of the universe. The code is the universe itself. This leads to a staggering implication. If our reality is one particular mathematical structure, what about all the others? Every mathematically consistent system, every possible geometric configuration that does not contain logical contradictions, must exist as a physical reality somewhere in the multiverse. There is a universe governed by the rules of simple Euclidean geometry, another by the bizarre algebra of a six-dimensional sphere, and countless others beyond our imagination. We do not exist in a special cosmos. We simply inhabit one mathematical structure out of an infinite ensemble. Our particular structure happens to have the specific set of mathematical properties that allow for stars, planets, and conscious observers to emerge. This idea is both humbling and empowering. It suggests that the ultimate nature of existence is not mysterious or spiritual in a conventional sense. It is computational and structural. We are living inside a grand dynamic equation, and every discovery we make is simply us reading another line of our own source code. The search for a theory of everything, then, is not a search for the Creator's rulebook. It is the process of figuring out which particular mathematical structure we are. If the universe is a mathematical structure, then what is it calculating? Digital physics takes this idea to its logical extreme, proposing that reality is not just analogous to a computer, it is one. The cosmos is not merely described by computation. It is a computation. This radical perspective was championed by pioneers like Konrad Zuse and Edward Fredkin, who dared to suggest that the universe is the output of a program running on a cosmic scale machine. In this view, the hidden geometric code we have been exploring is not just a description. It is the literal data structure of reality. Spacetime is not a smooth, continuous sheet. It is a vast, discrete lattice of finite points, a cosmic grid where each point holds a single bit of information. The laws of physics, from gravity to quantum mechanics, are not fundamental forces. They are the algorithms, the software routines that process this information. These algorithms run on a cosmic clock cycle, updating the state of every point in the lattice from one moment to the next, calculating the entire history of the universe step by deterministic step. Think of a breathtakingly complex cellular automaton like Conway's Game of Life, but operating on the scale of the entire cosmos. In that simple digital world, a grid of cells follows basic rules, like a cell being born if it has 3 neighbors or dying if it has too few. From these minimal, algorithmic instructions, astonishing complexity emerges with patterns that move, interact, and even replicate. Our universe could be the ultimate expression of this principle. The chair you are sitting on, the light from a distant star, the feeling of a thought in your mind, all of it is the result of a near-infinite number of discrete calculations updating the cosmic grid. This reframes the entire quest for a final theory. The search for a theory of everything is no longer a hunt for elegant equations. It becomes a hunt for the universe's source code. We are not looking for the laws of physics. We are looking for the programming language in which those laws are written. What are the fundamental data types? What is the core logic that governs the main loop? Is the program deterministic, following an unbreakable chain of cause and effect, or is it probabilistic, with a random number generator built into its heart? Finding this code would be the ultimate act of reverse engineering, allowing us to read the universe not as a story written in particles and forces, but as a program written in pure information. This forces a profound question about our own existence. Are we merely intricate patterns emerging from this cosmic computation, or are we, in some way, part of the program itself? This fine-tuning is so precise it feels almost intentional. The strength of gravity, the mass of an electron, the exact force that holds atomic nuclei together, each of these fundamental constants is dialed to a value that seems impossibly perfect. If gravity were even slightly stronger, the universe would have collapsed back on itself in a catastrophic crunch moments after the Big Bang. If it were slightly weaker, matter would have flown apart so rapidly that stars and galaxies could never have coalesced from the primordial haze. The same is true for the other forces. A tiny change in the nuclear strong force and carbon, the essential building block of life as we know it, would never form inside stars. We exist in a universe that seems to have won a cosmic lottery, with every single physical constant holding the exact winning ticket. The sheer improbability of this perfect balance has led some to search for a deeper, geometric reason. Perhaps the answer lies not in a single universe, but in a near infinity of them. This is the core of the anthropic principle. Imagine a vast cosmic landscape, a multiverse where every possible set of physical laws and geometric properties is realized in its own separate bubble universe. Most of these universes would be stillborn or form for only an instant before collapsing into nothing. Others would expand forever as cold, empty voids, their geometry too simple to build any complexity. In this infinite ensemble, a tiny fraction of universes would, purely by random chance, possess the precise geometric and physical parameters that allow for stars, planets, and eventually, life. We are not in a special universe. We are simply in one of the few that is bio-friendly, because we could not possibly find ourselves anywhere else. It is like a puddle of water marveling at how perfectly the hole it sits in conforms to its shape. The puddle thinks the hole was designed for it, when in reality, it simply filled the only hole that could hold water. Our universe is that puddle. The specific geometric code we have been exploring, the hologram, the spin networks, the symmetries, might be just one version of the cosmic software. There could be countless other versions running, producing universes with 4 spatial dimensions, or with no weak nuclear force, or where gravity is repulsive. We are simply experiencing the output of one particular, life-permitting program. This shifts the question from why our universe is fine-tuned to why we find ourselves within this specific, habitable slice of a much vaster and stranger multiversal reality. This accelerating expansion is perhaps the single greatest surprise in modern cosmology. We have a name for the force behind it, dark energy, but its true nature remains a profound mystery. It seems to be a property of empty space itself, a constant energy density woven into the very vacuum. Imagine the vacuum not as a true void, but as a seething, bubbling sea of virtual particles that constantly pop in and out of existence. This quantum frenzy gives every cubic centimeter of what we call nothing a tiny, intrinsic energy. According to Einstein's revolutionary insight, energy and mass are equivalent, and they curve space-time. So this vacuum energy, this energy of nothing, should produce a gravitational effect. But here is the cosmic riddle. When we calculate how much gravitational push this quantum vacuum should produce, the number is absurdly, impossibly large. It should have torn the universe apart in its first instant. The observed effect of dark energy is real, but its strength is 120 orders of magnitude weaker than our simplest theoretical predictions. This is not just a small error. It is the worst mismatch between theory and observation in the entire history of science. This colossal failure suggests we are fundamentally misunderstanding the geometry of emptiness. Perhaps dark energy is not a substance at all, but a clue that Einstein's beautiful geometry of general relativity, where matter tells spacetime how to curve, is incomplete on the vastest scales. Maybe the cosmic code contains a new, hidden variable that modifies the geometry of the universe as it expands. Unraveling this mystery means deciphering the true geometric nature of the vacuum. Is the accelerating expansion a signature of the universe's holographic boundary, a projection from the edge? Or is it a thermodynamic effect, like a pressure emerging from the increasing information content of spacetime? The answer will rewrite our understanding of cosmic geometry, revealing whether the emptiness between galaxies is truly empty, or if it is the most dynamic and geometrically rich component of all. But these loops and pixels of space are not the final word in our geometric journey. Another, even more ambitious, framework attempts to weave gravity and quantum mechanics into a single geometric tapestry by proposing that the most fundamental level of reality is not a point nor a loop but a vibrating string. In string theory, the ultimate ingredients of the cosmos are unimaginably tiny, one-dimensional filaments of energy. Each type of fundamental particle, from the humble electron to the lofty Higgs boson, is not a dot. It is a distinct note played on these cosmic strings, a unique resonant frequency in their vibration. A string vibrating one way manifests as an electron with its specific mass and charge. A string vibrating with a different harmonic pattern becomes a photon, the particle of light. The entire symphony of the universe, with all its diverse particles and forces, emerges from the music of these strings. For this beautiful idea to work mathematically, the universe must have more than the three spatial dimensions we experience. String theory demands extra dimensions, curled up into shapes of such intricate complexity and minute scale that we are utterly unaware of them. These are the Calabi-Yau manifolds. Imagine the universe as a vast four-dimensional ocean. Every point in this ocean is not just a location, but a tiny six-dimensional geometric labyrinth, a Calabi-Yau shape far too small to see. The specific topology of this hidden manifold, the number of holes it contains, the twists in its geometry, and the way its dimensions are folded, dictates everything. It determines the number of particle families, the strength of the forces, and even the value of the cosmological constant. The resonant patterns of the strings are entirely dependent on the geometric stage they are playing on. So, the search for a single, unifying theory of physics transforms into a search for a specific shape. Finding the theory of everything is equivalent to sifting through a near-infinite landscape of possible Calabi-Yau manifolds to find the one unique geometric form whose hidden, compactified dimensions produce, through the vibrations of strings, the exact universe we observe. Our entire physical reality, with its specific laws and particles, is a direct consequence of the geometry of this unseen, six-dimensional space. The cosmic code is not just written in shapes we can visualize. It is written in the topology of dimensions we cannot even perceive. This pursuit of a single, elegant source code finds its most ambitious expression in a shape of almost unimaginable symmetry. Deep within the abstract world of mathematics lies a structure known as the E8 Lie group, a geometric entity living in 248 dimensions. To call it complex is a staggering understatement. It represents one of the exceptional simple Lie groups, the rarest and most perfect forms of symmetry possible in the language of mathematics. Its geometry is so intricate and self-contained that it has been described as a cosmic diamond, a jewel of pure relation. The audacious proposal is that this single, magnificent object could be the universe's master blueprint. In this controversial vision, every particle and every force we know is not a separate entity, but merely a different facet of this one geometric form. The electron, the quark, the photon, and even the gravitational force itself are all understood as unique vibrations or manifestations of the E8 symmetry. It is an attempt to derive the entire chaotic zoo of the Standard Model and the cosmic curvature of general relativity from one unified source. Imagine finding a single, compact seed that contained, in its internal crystalline structure, the complete genetic instructions for every tree, every animal, and every ecosystem on an entire planet. The E8 group is proposed to be that seed for our cosmos. The mathematics suggests that the specific charges, spins, and masses of the particles that build our reality are not random numbers. They are the inevitable outputs, the fixed properties that emerge when this perfect, higher-dimensional symmetry is broken or projected down into our familiar four-dimensional world. The theory remains deeply speculative and faces significant hurdles, but its power lies in its sheer geometric ambition. It pushes the idea of a cosmic code to its logical extreme, suggesting that the universe's entire operating system could be written in just a few lines of breathtakingly beautiful, symmetrical logic. This discovery reshapes our very definition of reality. Jacob Bekenstein and Stephen Hawking uncovered a cosmic rule so counterintuitive it seems to defy logic. They found that the maximum amount of information, the total number of bits that can be stored in any region of space, is not determined by its volume. It is fixed by its surface area. Think of a box. You might assume that a bigger box with more cubic feet of space inside can hold more data, but the universe operates differently. The ultimate storage capacity of that box is set by the square feet of its outer surface. This is the Bekenstein bound, a fundamental limit on information density woven into the fabric of the cosmos. It is the universe's own version of a hard drive specification, a maximum number of bits per square Planck area that cannot be exceeded. This principle finds its ultimate expression in the most enigmatic objects we know, black holes. The information about every single star, every planet, every atom that has ever fallen into a black hole is not lost within its mysterious depths. It is perfectly and completely encoded on the two-dimensional surface of its event horizon. The three-dimensional interior we imagine is a projection, a holographic reconstruction of that surface data. This is the profound link between geometry and information. The universe is not simply filled with information like books in a library. The universe itself appears to be information. The geometry of space, with its curves and angles and surfaces, is the physical medium, the cosmic hard disk on which this information is written, stored, and processed. The solidity of the world around you is the readout of this data. The flow of time may be the processing of this data. We are not just made of atoms. We are made of cosmic bits, and the geometry of reality is their ultimate language. The universe might be running on a grid. This is not a metaphor for a supercomputer, but a literal description of reality's architecture. Picture an infinite, shimmering lattice, a cosmic chessboard where each square is a fundamental cell of spacetime. These cells are not empty. They hold a single bit of information, a 1 or a 0, an on or an off state. And just like in a simple computer game, the entire cosmos evolves from one moment to the next by following a basic, local rule. The state of each cell at the next instant is determined solely by its own current state and the states of its immediate neighbors. There is no grand plan, no central controller. There is only the relentless, simultaneous execution of this single, elegant instruction across the entire grid. From this breathtakingly simple process, everything we know emerges. The most famous illustration of this power is Conway's game of life. Its rules are almost childlike. A live cell with too few neighbors dies of loneliness. A live cell with too many neighbors dies of overcrowding. A live cell with just the right number lives on. And a dead cell with exactly 3 live neighbors springs to life. That is all. Yet from these minimal instructions, an entire universe of complexity blossoms. Gliders stream across the grid, acting like coherent particles. Still lifes form stable, crystal-like structures. Even self-replicating patterns can be engineered, mimicking the most fundamental property of biology. This is not a simulation of life. It is a demonstration that life-like complexity is a natural product of simple, algorithmic rules. physicists like Stephen Wolfram have taken this insight to its ultimate conclusion. He proposes that our own physical universe is a cellular automaton of a similar kind, just with a different, more sophisticated rule set. In this radical view, the fundamental laws of physics, from quantum electrodynamics to general relativity, are not the primary reality. They are emergent phenomena. They are the large-scale, approximate descriptions of the complex patterns that arise from the cosmic grid's underlying discrete computation. An electron is not a tiny, solid ball. It is a persistent, dynamic pattern of ones and zeros flickering across the lattice. A gravitational field is not a smooth curvature of a continuum. It is a particular configuration of information in the grid that our mathematics interprets as curvature. The entire history of the cosmos, from the Big Bang to the formation of galaxies, is the output of a single, universe-spanning calculation that has been running for 14 billion years. This transforms our search for a final theory. We are no longer hunting for a set of complex differential equations. We are searching for the universe's single line of code, the concise rule that, when iterated over a near-infinite grid, generates the breathtaking reality we inhabit. The cosmic code may not be written in the language of mathematics, but in the even more fundamental language of computation itself. This timeless block of reality might sound like a philosophical abstraction, but it emerges from a hard mathematical equation. The Wheeler-DeWitt equation represents one of the most ambitious attempts to unify the two great pillars of modern physics, quantum mechanics and general relativity. Yet when physicists derived it, they encountered something deeply strange. The variable for time simply vanished from the final equation. It was not hidden. It was gone. The master code for a quantum universe seems to have no place for time as a fundamental ingredient. The universe it describes is not a process unfolding in time. It simply is. This points toward a breathtakingly static vision of reality, often called the block universe. Imagine the entire cosmos, from the fiery flash of the Big Bang to the last flicker of the farthest star, not as a sequence of events, but as a single, immense, four-dimensional sculpture. Your birth, the rise and fall of civilizations, the death of the sun, all exist with equal reality, frozen in the geometric amber of this eternal block. So where does our powerful, undeniable sensation of a flowing present come from? The answer may lie not in the universe itself, but in us. We are complex patterns within the block, and our consciousness is a process that tracks correlations between states. You remember the past because your brain's current state is correlated with the state of the world a moment ago. You anticipate the future because you can predict, with reasonable accuracy, how your present state will correlate with future configurations. The flow of time is the feeling of moving through these nested correlations within the static whole, like a scanner reading a line of code. The entire history of the universe is already written, a complete and unchanging geometric object, and our journey is simply the act of discovering its contours one moment at a time. This means the cosmic code does not generate a story. It is the entire story printed on a single, timeless page. This quantum foam is the final, turbulent frontier where our two most powerful descriptions of reality collide. General relativity paints the cosmos on a grand scale, a smooth, curving stage where planets and stars perform their gravitational dance. Quantum mechanics reveals a microscopic world of frantic probability and uncertainty, where particles flicker in and out of existence. Both theories are spectacularly successful in their own domains, but they become mutually incomprehensible when forced to meet. The very stage that relativity says is smooth and continuous, quantum mechanics insists must be jittery and discrete. This is not a minor philosophical disagreement. It is a fundamental clash at the heart of physics, and it erupts with full force at an almost unimaginably tiny distance known as the Planck length. To grasp this scale, picture shrinking a single atom down to the size of our entire observable universe. On that colossal scale, a single Planck length would be roughly the size of another atom. It is the absolute lower limit, the universe's ultimate pixel size. At this infinitesimal scale, the smooth fabric of spacetime predicted by Einstein shatters. The Heisenberg uncertainty principle, a cornerstone of quantum theory, dictates that energy and time are locked in a chaotic dance. You cannot precisely know both at once. This means that over extremely short time intervals, there is a tremendous uncertainty in energy. This uncertainty fuels the vacuum, allowing vast amounts of energy to be borrowed from nothing, so long as it is paid back almost instantly. This quantum frenzy manifests as a seething ocean of virtual particle pairs popping into existence and annihilating each other. But when gravity enters the picture, something even stranger happens. John Wheeler realized that these wild energy fluctuations would warp the very geometry of spacetime itself. The borrowed energy distorts the fabric of reality, creating a turbulent foam. In this foam, the classical ideas of before and after, here and there, break down completely. Wormholes, tiny bridges connecting separate points in space, constantly form and pinch off. Microscopic black holes blink into existence and evaporate in a flash. The geometry of space becomes a churning, probabilistic froth, more akin to the bubbling surface of a boiling pot than a still pond. This is not empty space. It is a dynamic, geometric structure, the quantum geometric code of the vacuum itself. Writing a complete cosmic code means deciphering the rules that govern this chaotic, foamy foundation. It requires a new mathematics that can describe how this probabilistic foam averages out, across trillions upon trillions of these fluctuations, to produce the smooth, reliable stage of spacetime we experience every day. How does this roiling quantum sea calm itself into the continuous geometry that allows planets to orbit and light to travel in straight lines? The answer is the final piece of the puzzle, the line of code that unites the very large with the very small, revealing the true, fundamental texture of everything. But mathematical elegance alone cannot confirm a physical truth. The real test is whether we can find its fingerprints in the cosmos. The immense challenge of probing a geometric code is pushing science to its absolute limits, forcing us to build instruments sensitive enough to read the faintest whispers from the fabric of reality. One promising avenue is to scrutinize the oldest light we can see, the cosmic microwave background. Researchers are not just mapping its temperature, but its polarization, the specific direction in which its light waves oscillate. A unique swirling pattern in this polarization, known as B modes, could be the long-sought signature of primordial gravitational waves. These would be tremors from the universe's violent first moments, potentially carrying direct information about the geometric structure of spacetime at energies trillions of times higher than any particle collider can reach. Finding the right pattern could reveal the initial quantum geometric fluctuations from which all structure grew. Another frontier lies in the study of the most energetic particles in the universe, cosmic rays. These subatomic bullets, accelerated to nearly the speed of light by distant cataclysms, carry incredible energy. If spacetime is truly discrete, a pixelated grid at the Planck scale, then these ultra-high energy particles might stumble upon its graininess. As they travel for billions of years across the cosmos, a minuscule effect of this discrete structure could accumulate, subtly altering their speed or interaction in a way that smooth, continuous spacetime would not allow. Detecting this would be like feeling the texture of a fine fabric by dragging a needle across it. the recent dawn of gravitational wave astronomy has opened an entirely new window. When black holes or neutron stars collide, they send ripples through spacetime itself. Advanced observatories like LIGO and Virgo are now listening to these cosmic chords. Scientists are searching for faint echoes in the signal, tiny reverberations that could be caused by the quantum foam at the Planck scale, or by the existence of extra, compactified dimensions warping the waves as they travel to us. It would be like hearing a bell ring in a cathedral and detecting, in its fading tone, the precise shape and texture of the walls. Beyond these observational efforts, a different kind of experiment is underway in supercomputers around the world. If we cannot yet see the quantum geometry of gravity directly, we can try to simulate it. Researchers are running complex models of causal dynamical triangulations and spin foams, watching to see if a large, smooth, four-dimensional universe truly does emerge from the chaotic connections of billions of simulated geometric tiles. Success would not prove our universe works this way, but it would demonstrate that it certainly could, providing a crucial proof of concept. The search for the cosmic code is not a passive philosophical exercise. It is an active technological hunt, driving the creation of ever more sensitive detectors and more powerful computers. We are essentially building the first universal decryption devices, tools designed to read the source code of reality from the data the cosmos has been broadcasting since the very beginning. This coded reality forces us to confront the nature of our own minds. If the cosmos is a geometric program, then what are we? Are our thoughts, our choices, and our very consciousness just more complex outputs of the algorithm, predetermined from the first line of cosmic code? It is a chillingly mechanical thought that free will might be an intricate illusion, a feeling generated by a system processing its instructions. Yet there is another, equally startling possibility. The strange rules of quantum mechanics suggest that an observer is necessary to collapse probabilities into definite outcomes. What if our act of observation, our conscious attention, is not a passive reading of the code, but an active part of its execution? In this view, the universe requires a mind to decode it, to transform potentiality into concrete reality. We are not just running the program, we are the user interface. This dissolves the ancient barrier between the physical and the informational. A rock is not just a collection of atoms, it is a stable, persistent pattern of data in the cosmic computation. Your mind is not a ghost in the machine. It is the machine becoming aware of its own processing. We are the universe's way of understanding its own geometric language. This leads to a profound shift in philosophy. Existence is not about isolated objects, but about relationships and logic. The universe is a vast, dynamic network of connections, and our consciousness is a localized node within that network, experiencing the flow of information. So, what is knowledge in such a world? It is not merely collecting facts about external objects. It is the process of the system mapping its own internal structure. When we discover a law of physics, we are not uncovering a separate rulebook. We are reading our own source code. This makes every scientific discovery a form of cosmic self-recognition, and every conscious moment a unique decryption of the timeless geometric whole. The infamous measurement problem strikes at the very heart of reality. Why does the mere act of looking force a quantum system to make up its mind? Before observation, particles exist in a shimmering cloud of potential, a superposition of all possible states. The moment we measure, this cloud collapses into a single, definite outcome. This has led some physicists to a radical, almost unsettling possibility. What if consciousness itself is the trigger? In a cosmos built from geometric codes, perhaps consciousness is not an accidental passenger. It could be the fundamental process that translates potential into actuality, the user that compiles the cosmic source code into a tangible experience. This is not to say your thoughts magically create rocks and trees. Instead, it suggests that the geometric informational structure of the universe requires a conscious observer to render its calculations into a shared, consistent reality. Your awareness might be the universe's way of looking at its own data, of resolving the endless probabilities of the quantum foam into the stable, classical world we navigate. This paints a picture of a deeply participatory cosmos. We are not separate from the geometric stage. Our act of observation is an integral part of the performance, a necessary interaction that completes the circuit of existence. The observer and the observed are woven from the same informational threads, two expressions of a single, self-referential geometric truth. So the next time you look up at the stars, consider this. You are not just a passive witness to a distant light show. You are an active participant in its very realization, a node in the cosmic network where the silent, geometric code of the universe finds its voice and becomes real. These geometric patterns are not confined to the silent emptiness of space. They resonate just as powerfully within the vibrant, living world around us. The same cosmic code that carves out galaxies seems to be woven directly into the fabric of life. Consider the very blueprint of your own existence, the DNA molecule. Its iconic double helix is not a random tangle. It is a precise geometric spiral, a staircase of information whose form is perfectly suited to its function of storing and replicating the instructions for a living being. This is not an isolated example. Look at a tree with its trunk splitting into branches which then split into smaller twigs. Examine the network of veins in a leaf or the intricate pathways of your own circulatory and nervous systems. They all share a common geometric signature, the fractal pattern of branching that maximizes surface area and efficiency. Life has discovered that this recursive, self-similar geometry is the optimal way to distribute resources, from sunlight and water to oxygen and nutrients. This biological wisdom reaches its most beautiful expression in a sunflower. The seeds in its center are arranged in two sets of spirals, one winding clockwise and the other counterclockwise. If you count these spirals, you will almost always find two consecutive numbers from the Fibonacci sequence, a series where each number is the sum of the two before it. This same pattern dictates the number of petals on many flowers, and it is intimately connected to the golden ratio, a number known to the ancient Greeks that appears in the proportions of everything from seashells to the Parthenon. What we are seeing is not mere coincidence. It is a powerful clue that biology is not operating on a separate set of rules. The growth of a plant, the structure of a cell, the very rhythm of a heartbeat, these are all biological algorithms. And these algorithms appear to be running on a subset of the universe's fundamental geometric operating system. The patterns that govern the large-scale structure of the cosmos are the very same patterns that life has harnessed to build complexity and ensure its own survival. This suggests a staggering unity, a single source code expressing itself in both the silent dance of galaxies and the quiet unfurling of a leaf. Our relentless search for a unifying language is driven by a simple, profound question. What is the universe's native tongue? If reality is indeed a cosmic code, then our most successful theories, from quantum mechanics to general relativity, might not be the final word. They could be like different high-level programming languages, such as Python or C++. Each one is powerful and elegant in its own domain, capable of describing vast swaths of reality with stunning accuracy. Yet, underneath it all, they must all compile down to the same fundamental machine code, the raw binary instructions that run on the universe's processor. This is the grand quest of theoretical physics, to find that master language. The mathematical universe hypothesis argues that mathematics itself is this final layer, that we live inside a complex, self-consistent mathematical structure. But is math the source code, or is it merely the most powerful tool we have for describing the output? Perhaps the true foundation is something even more elemental, pure information, or the immutable rules of logic. Think of the strange duality between gravity, described by the smooth geometry of spacetime, and quantum physics, which governs the frantic particle dance. They seem utterly incompatible, written in different dialects that should not be able to communicate. Yet both must be approximations of a deeper, unified description. This is the challenge of reverse engineering the cosmos. We have the compiled program, the universe we see around us, and we are trying to work backwards to find the original, elegant source. Discovering this cosmic machine code would be more than just a scientific triumph. It would be the ultimate act of understanding, allowing us to read the blueprint of existence itself and finally see the hidden logic behind every particle, every force, and the very fabric of reality. Deciphering the cosmic code would be the ultimate technological revolution. This is not about finding a new energy source, but about learning to reprogram the very operating system of reality. Imagine our current technology as a collection of apps running on a device we do not fully understand. We know how to use some of the features, but we have no access to the source code. Understanding the universe's geometric language would be like gaining administrator privileges. The first and most profound applications would likely be in energy. The quantum vacuum is not a true void, but a seething sea of geometric activity, a foam of unimaginable energy. If we could comprehend its structure, we might learn to stabilize a tiny region of this foam, coaxing out a fraction of that latent power. This would not be burning fuel, but tapping directly into the background energy of spacetime itself, a source that is literally everywhere. The implications for computing are equally staggering. Our current quantum computers are incredibly delicate machines, struggling to maintain coherence as they perform calculations. But if quantum states are fundamentally geometric, as theories like the Amplitudehedron suggest, then a true geometric quantum computer would not fight decoherence. It would embrace it as part of the calculation, using the natural evolution of geometric shapes to solve problems that would take a classical computer the age of the universe to crack. Such a machine would not just be faster, it would be thinking in a different language, the native tongue of the cosmos. Looking further ahead, the ultimate application would be the direct engineering of spacetime. The equations of general relativity already allow for solutions that describe warp drives and traversable wormholes. These are not forbidden by physics, but they require a form of matter with negative energy density, something we do not know how to create. However, if spacetime itself is a geometric construct, a dynamic network of information, then manipulating its structure might not require exotic matter. It might require the right algorithm. We could learn to write code that changes the topology of the cosmic network, pinching two distant points together to form a bridge, or smoothing out the fabric in front of a ship to create a warp bubble. This would not be propulsion in the conventional sense. It would be navigation by recompiling the geometry of reality. The power to rewrite the cosmic source code would transform humanity from passive inhabitants of the universe into active participants in its design. Yet for all its elegance, the geometric vision of the cosmos faces serious and necessary challenges. A fundamental criticism is that some of these theories currently reside in a liminal space between science and philosophy, beautiful mathematical constructs that have not yet been subjected to decisive experimental tests. The primary demand of the scientific method is falsifiability. the ability for a theory to be proven wrong. For ideas like the intricate Calabi-Yau manifolds of string theory or the specific geometry of the E8 group, the mathematical complexity is immense, but the unique, verifiable predictions that would distinguish them from other potential models have been elusive. After decades of work, we have not yet found a way to probe these extra dimensions or confirm this master symmetry in a laboratory. This leads some physicists to worry that the pursuit of a purely geometric universe, while intellectually stunning, might be steering us into a realm of metaphysics where the map becomes so detailed and self-referential that we risk losing sight of the territory it is meant to describe. Another compelling counterpoint comes from a different direction entirely, the paradigm of emergent gravity. In this view, spacetime and its geometry are not the foundation of reality. They are the consequence. Proponents suggest that the smooth, curving stage of the universe emerges from something even more primitive, the quantum entanglement of information. Think of it this way: the very connectivity of space, the fact that you can move from your chair to the door, might be a direct result of countless underlying quantum links between the fundamental constituents of reality. In this picture, gravity is not a fundamental force described by geometry, but a thermodynamic force, an entropic effect that arises from the natural tendency of this quantum information to become more disordered and interconnected. It is as if the force we call gravity is a collective illusion, like the pressure of a gas emerging from the frantic motion of trillions of molecules. Engaging with these criticisms is not a sign of weakness in the geometric quest. It is the essential process of scientific rigor, the constant questioning that prevents any idea, no matter how beautiful, from becoming dogma. The true nature of the cosmic code remains one of the great open questions at the very frontier of knowledge. We are left with a humbling and thrilling realization. The universe is whispering its secrets in a language we are only beginning to decipher, and the final chapter of this story is far from written. Multiple paths of inquiry are converging on a single, startling vision. The frantic quantum realm, the vast cosmic stage, and the intricate dance of particles all whisper the same secret. Reality is not a collection of separate things, but a unified system written in a geometric and computational language. The hologram teaches us that information is fundamental, encoded on lower dimensional surfaces. The spin networks of loop quantum gravity reveal that space itself is woven from discrete, quantized threads. The cosmic web displays its fractal architecture, and the symmetries of particle physics act as the inviolable rules of the game. Each of these discoveries, from wildly different domains, points toward a cosmos built from a fundamental code. This code uses geometry as its native tongue, with the immutable rules of mathematics as its grammar. We are witnessing a grand synthesis where physics, computer science, and mathematics are merging into a single, unified quest. The universe is beginning to look less like a machine and more like a sublime, self-executing calculation. While the final equation remains just beyond our grasp, this powerful convergence of ideas tells us we are not lost in a maze of possibilities. We are following the faint, geometric footprints of reality itself, leading us toward the ultimate source code of existence. Our journey ends with a cosmos that is far more structured and logical than it first appears. The chaos of exploding stars and swirling galaxies begins to resolve into the intricate patterns of a deeper design. From the holographic projection of our reality to the fractal architecture of the cosmic web, we have seen hints of a fundamental code, a language written not in words but in the silent, perfect grammar of geometry. This perspective weaves together the immense and the infinitesimal, revealing a universe that is not just described by mathematics, but may, in its very essence, be mathematics. We stand at a remarkable threshold in human understanding, where the age-old question of what reality is made of is transforming into a new and even more profound inquiry. We are no longer just asking what the rules of the universe are. We are asking what language those rules are written in, while countless mysteries remain, from the true nature of dark energy to the final unification of all forces. The pursuit of this cosmic code represents one of humanity's most noble and profound endeavors. It is a quest to read the blueprint of existence itself. Let this exploration be a starting point for your own curiosity. What do you think? Is the universe a grand computation running on a cosmic scale, a majestic mathematical structure, or is it something entirely beyond our current imagination? We would love to hear your perspective. Share your thoughts in the comments below. Subscribe for more deep dives into the mysteries of the cosmos, and never, ever stop questioning the nature of reality.